Hello everyone, let us now discuss trigonometric leveling. Okay, so in this type of leveling, we can use a total station or a theodolite for measuring the difference in elevation. So let's examine the figure here. As you can see, we have here our instrument set up above point A. We have here our vertical angles, we have here the zenith angle and also the altitude angle. And we have here our height of instrument, and V right here, which is the difference, the vertical distance from the height of instrument to the rod reading, and also R, which is the rod reading. Okay, so if we want to calculate for the elevation of B, so elevation of B is equal to the elevation of, this is the elevation of A, then plus the height of instrument, and then plus V, right? And then minus R, the rod reading. Okay, so this is the formula for getting R. So how about V right here? How about V? How do we get V? So for getting V, we just need to use SOHCAHTOA for that. Let's say we want to use the altitude angle. So sine alpha will be opposite, which is V over the hypotenuse, which is S. So our V is equal to S sine of alpha. So this is formula for V if you use alpha. What if you use the zenith angle? So for the zenith angle, use this triangle, see right here. So this will be our V right here. So if we want to use that, we can use cosine of Z. Okay, see the zenith angle. So that would be V over the hypotenuse, which is S. So you can also get V by S times cosine of Z. Okay, so there you have it. Okay, so in this next figure, um, this is a little bit more complicated because of the effect of curvature and refraction. So as the distances increase, so you need to take into account the effect of curvature and refraction. So as you can see right here, we have here the error caused by the curvature of the Earth. And then we also have here the error caused by refraction. So as the distance increases, so the level line is right here, right? So this error right here, we have to compensate for this error due to the curvature. And the refraction, so this occurs because things appear higher than where they actually are. So that is the effect of refraction in the atmosphere. Okay, so in order to calculate for the combined effect of curvature and refraction, we have different formulas for that depending on the unit of measurement that you're going to use. So let's say, for example, your unit of measurement is feet. Okay, so HCR for that would be 0.0206, then F squared. Okay, now this F right here is the horizontal distance. This is the horizontal distance right here. Now this is not the slope distance. Okay, you have to take note of this. This is not the slope distance. This is the horizontal distance, and also F is not um, the horizontal distance itself. F is the horizontal distance divided by uh, HD over 1000. Okay, so F is thousands of feet. You have to take that into account. Okay, or if your distance is in mile, so 0.0574 m squared. So this is in miles, so no need to divide 1000 for that. Or you can also use 0.0675 k squared. Okay, so k here is in kilometers. Okay, so out of these three, you need to look out for F. Okay, so if we want to calculate for the elevation of B in this case, elevation of B is equal to elevation of A plus HI, and then um, to take into account the curvature refraction, so just add the HCR plus V and then minus R. Okay, so there you have it. This is the formula for the curvature and refraction. I mean, finding B, taking into account curvature and refraction. Okay, so if you also want to find the horizontal distance, so the horizontal distance is equal to, so you just use SOHCAHTOA as well. So if you want to use the zenith angle, so the zenith angle for that would be a sine z is equal to horizontal distance, that would be the opposite, over the hypotenuse, which is our s. So horizontal distance would be s sine z. Now if you want to use the altitude angle, then you can use cosine for that. So cosine of alpha is equal to horizontal distance all over s. So you have hd is equal to s cosine alpha. Okay, so now this is what you're going to use for the computation of HCR. Okay, so that's basically it for trigonometric leveling. So what we're going to do in the next video is to solve an example. Okay, thank you for watching this video. I hope you learned something or refreshed your memory about this, and I will see you in the next video.